Now what?
You set them equal to each other?
We'd still have two unknowns if I assume because they're both equal to zero.
Yeah.
Yeah, that is equal to that, but we'd still have one equation with two, then we'd have one equation with two unknowns, which the math people frown upon.
Set it equal to B, and then plug B in the other one, or?
All right, so solve for B.
Yeah,
Which one do you want to solve it, the first one or second one?
the first one.
All right, so if we do that, we get, I'm gonna bring that over, so I have 15 plus 7C equals 14B. So B is equal to 15/14 plus, well, 1/2 C. Plug that into there, -1 plus 7 times 15/14 plus 1/2 C minus 9C equals 0. -1 plus, because that's 15 halves, plus 7 halves C minus 9C equals 0. So 13 halves, 18 minus 11 halves C equals 0. So that becomes 13 halves equals 11 halves C. So C equals 13 elevenths. Unless there's a Carol's error.
Not sure.
Alright. So we've established, we got a positive answer over there, so we picked the correct direction for C. And so that is equal to 13 elevenths amperes. And this is why I probably should not have picked the letter A over here as my variable, but that's a unit.
Then can we plug C into any one of those equations with a B variable?
Well, we got one right here where B equals something in terms of C, so I have 15/14 plus 13/22 equals B. And I'm also getting a positive number, so we pick the correct direction for B. And so it's equal to something absolutely wonderful that someone's about to tell me. So somewhere around 1.7.
$1.66.
Yeah.
Then the simple A plus C equals B.
Alright, so we had, so A equals B minus C, so that becomes 1.66 minus 13 elevenths. Something small, 0.4 something. 0.47.
I got .48.
Okay. So we'll put it over here. This might be off video, but it should not matter. So A is 0.48 amperes. Oh, let's go ahead and put the formality. I sub A, I sub B, 1.66 amperes, I sub C. What's 13 elevenths? Is it? No, wait, that is 13 elevenths.
1.81818181818181.
1.18 continued.
about to do a different technique of solving this mathematically. Any questions up to here before I start erasing, or anybody need me to wait before I erase? Kramer's rule, any of you done Kramer's rule before?
Say it again?
Kramer's rule, Kramer with K. Swiss mathematician, you would, if you took, so there's Calc 1, Calc 2, Calc 3, and was it linear algebra? Yeah, if you've taken linear algebra, you would have eventually done it in math. All right, did not hear a lot of, oh yeah, Kramer's rule, it's great.
I think I might have taken it in differentials. It sounds familiar, but I don't know where I saw it.
Matrices?
Yeah.
That sounds familiar.
Found out, I was reading the history of mathematics, they figured out Kramer's rule before they ever figured out matrices, which still seems odd to me, but. Oh, I erased more than I wanted to. Oh, what are my three equations? So, I'll put them down here. So I had A plus B equals C.
A plus C equals B.
Thank you. And then the first abbreviation of the equations, what were those?
15 minus 7A minus 7B equals 0. And then the other one is minus 1 plus 7A minus 2C equals 0.
All right, assuming that those equations are correct. When implementing Kramer's rule, you need to get all the ones with variables on one side in the correct order, and all the ones on the other side are the constants. So for the first one, I have no constants. My constant will be 0, but I'm gonna get B over to the other side, so I start out with an implied 1 in front of the A, 1A minus 1B plus 1C equals 0. Order does matter. You know, A doesn't have to be first, but whatever comes first is gonna be first in every equation. Whatever second is the same in every equation. The next one, because I don't want negatives in there, I'm gonna add 7A, 7B to the right side and then just flip it over. So I have 7A plus 7B plus 0C is equal to 15. And then the last one, 7A plus 0B minus 2C is equal to 1. And then I do a quick double check, make sure I didn't do something careless. Feeling good based upon the equations there. All right, determinants. Have any of you dealt with determinants before?
Going a little bit more.
If I've got, say, 1, 3, 4, 6, the determinant of that is
6 times 1 minus 4 times 3.
all right, so
That's the matrix. I get that from the matrix.
determinants are actually slightly different from a math point of view, but yeah, they're usually introduced at about the same time. So 2 by 2, it ultimately is that times that. 3 by 3, since we'll have a 3 by 3 here.
It'll be 1 minus 1 plus 1. Oh,
All right, so you're remembering part of it. 2, 4, negative 6, 8, negative 3. All right.
you would take 4, you would do 2, 4, 8, negative 3.
All right, yeah, cross out that row, that
Yeah.
column, and what you're left with is 2, 4, 8, negative 3.
And then you minus the 6.
Yep, then you're gonna alternate plus, minus, so plus, minus.
They never explained the why the minus, but my calc teacher said it's a long, drawn out process. He said forget about it.
And actually, it can get more complicated because you don't have to start here, you can start anywhere. And so if I started here, it'd be, and went this way, it'd be minus, plus, instead of plus, minus. And you can go up and it can get far more complicated. I'm just sticking to first row, going across the way Devon is laying it out. So -6, cross out that row and that column. I'm left with -1, 4, -6, -3, plus 7. Cross out that row and column, and I'm left with -1, 2, -6, 8. If you're writing a recursive program, you can do the exact same thing again, and ultimately it ends up with this diagonal minus that diagonal. So 4 times -6 minus 32, minus 6 times 3 minus -24, plus 7 times -8 minus -12. And then, so 4 times -38 minus 6 times 72 plus 7 times 4. And you get some number.
Is that only across the top row, not each?
You,
the 9
whatever
rows?
row or column you're picking, you just do that one, and it sets it up, that you're done.
Shouldn't be 72,
Should be 72.
should be 27. Negative 27.
Oh,
Or 21.
I did 3 times 24, not 3 plus 24.
Yeah.
And yet one more place for a careless error. Is that the only mistake so far?
Yes. This is definitely the most numbers we've used in physics for problems.
Say it again?
This is the most numbers that we've used in physics for
Yeah.
problems.
Yeah. Turns out there's a shortcut for a 3x3. Does it save you in numbers? Yeah, a little bit. Not really. The shortcut, ultimately, we had, this 6 comes from the 2 and the -3. So we ended up, this 4 times -6 is just 4 times 2 times -3, it's just that. This, we've had a negative there, we put a negative in there, so the 6 times, the -24 is just 6 times 4 times -6. And then you got 7 times -1 times 8, which is that right there. And then the other half, you're going in this direction. So I could have done the same thing with 4, -1, -6, 6, 2, 8, 7, 4, -3. Some people like this to repeat the first 2 columns again. It depends upon where your mind's working at the moment, you need to do it. So I take these diagonals and I multiply them and add them together. So that's -24 plus, I had to pick these numbers, 36 times 4, be 144. Negative, and then -56. Minus, going the other way, -84. Plus 128. Plus 18. And you should get the same answers you got right there. If not, then there's an error somewhere.
So both of these are per, I can't remember the person's name.
Oh, this is something you need to be able to do Kramer's rule.
Kramer's rule, okay.
Was it Kramer? Kramer from Seinfeld, was that with a K or a C?
I always assumed it was a K.
This Kramer's the other one, whichever, I think K was the one for Seinfeld, and this is Kramer C. All right, so let's actually deal with Kramer's rule now, that you're all experts with determinants. Or for some of you, I think there's a determinant button on the DI-80 whatever's. All right, so Kramer's rule is I'm gonna set up a fraction. So A, my first one, my denominator is just the coefficients right here for my A, B, and C. So 1, 7, 7, negative 1, 7, 0, 1, 0, negative 2. Just do a quick check, make sure I didn't get any signs off. All right, at least it matches that. So my denominator for every single one of my fractions is going to be the same thing. The numerator, this is why the order really matters. For which variable am I solving? Well, I'm solving for the first one, so I'm going to replace the first column. I'm going to replace the first column with what I have on the right-hand side of the equation. So I got a 0, 15, and 1. It's going to replace my 177, because I'm solving for A, and those are the ones associated with A. And the other two are the same as the denominator. And so now we just solved two determinants. So if I do this diagonal right there, I get 0. And then negative 1 times 0 times 1 is 0. And then 1 times 15 times 0 is 0. Minus, going the other diagonal. 1 times 7 times 1 is 7. Negative 1, 15, negative 2 is 30. And then 0 times 0 times 0. So my numerator is going to be negative 37. My denominator, well, I got to do determinant here. I have 1 times 7 times negative 2. One times 7 times negative, that's negative 14. Then negative 1 times 0 times 7. And then 1 times 7 times 0. Minus, the other way, I got 49 plus 14 plus 0. So that's negative 14 minus 53. Negative 67. And I hope that equals 0.48. What'd you get?
0.552.
So, do we make a mistake over there, or we make a mistake here?
Adding of the denominator?
Sorry? Where did I mess up?
That middle row.
All right, let's repeat the first two, so negative 1, 7, 0. So I got that diagonal there, which is negative 14, 0, and 0, minus 49, 0, and that's a 14. Such a little thing.
Yeah, 4.8.
Or 0.48. amperes. All right. I'm glad the mistake was there as opposed to something earlier. The nice thing is the new Kramer's rule for the other two, I already have the denominators, negative 77. That's going to be the same for all three of them. B, negative 77 is my denominator. The numerator is I'm replacing the second variable here. So my first and third rows stay the same as the denominator. And so the middle, I'm going to put in my 0, 15, and 1. So I end up with negative 30 plus 0 plus 7 minus, and that is a 0 there. 15 times 7. 105? 105 plus 0 plus 0. So it's negative 23 minus 105, negative 128. And so B, doing it this way, is negative 128 divided by negative 77.
1.66.
All right. And then C. Well, this is the hybrid technique. I'm gonna do Kramer's rule with C, but we also have this simple equation here that I probably would do if I were doing this solo. So C is equal to, well, my denominator, negative 77. My numerator, replacing the third variable, so that third column gets changed. So the first two are the same as the denominator, negative 1, 7, 0, and then 0, 15, and 1. Quick check, make sure I didn't get a sign off, okay? And so I'm left with 7 minus 105 plus 0 minus 0 plus 0 plus negative 7. Negative 91. Over, which is 13/11.
Oh, yeah.
So there's two math techniques there. There's also other techniques. When we were posed with this equation right here, you could also have gotten rid of an a by multiplying one of these equations by -1 and just adding them. Then we'd have it, say, if we multiply that by -1, we'd have 7a and negative 7a, so it would drop out. We'd have 7b and 2c and 14. If you've dealt with determinants and you're comfortable with what I've just done, and I have had students who just prefer this, even with the calculator, they know how to, they picked this and they stuck with it, and they were good with it. There also, there's some videos under chapter, whichever one it is, where I go through this again, so.
Would this be chapter 28 or?
Or 29. Sort of bored some chapters there.
Once we skip figure 99, 100.
All right. So this all started with our one current per path. I want to do a different technique for coming up with the equations.